carry on with the homework on trig identities, question 5. Okay, so this time we're given the value of cos, we're given a range of values for the angle theta, and we have to find the exact value of sine and then of tan. So you can do this with identities, but it's so much easier just to sketch a little right angle triangle. Okay, and then remember SOHCAHTOA. So in SOHCAHTOA, cos is adjacent over hypotenuse, so I need to pick an angle, doesn't matter which one. So this would mean my adjacent would be 2, my hypotenuse 3. Okay, so we can easily work out the opposite side using Pythagoras. So we're going to do 9 take away 2 and then root it, so that's root 5. So that then tells me that sine has got to be a value root 5 over 3, opposite over hypotenuse. But because of this, we need to think about whether sine is positive or negative. So you may remember from the graphs, or you can simply use cast. So in the area we're looking at, from 270 to 360, okay, theta's going to be in here. Actually, the full theta is the full thing. So we can see that only tan is positive here. So that means sine is negative. Okay? And then tan is opposite over adjacent. So we've got root 5 over 2. And this time we know that tan is positive. So that's it done. Okay. Number 6. This time we're given that tan theta is negative 3. Find in exact form the possible values of sine theta. Okay. So it says all possible ones this time. So we're going to start again with a right angle triangle, and we pick an angle to be theta, it doesn't matter which one. And tan is opposite over adjacent, so we've kind of got an invisible 1 there. So the opposite side would be 3, we can ignore the sign for our triangle, and adjacent side 1. I'm going to also sketch a cast diagram to help me with my signs. So we're looking at where where tan is negative. So tan is positive A and T, so it's negative here and here. Right. So if our angle was in here between 90 and 180, then sine will be positive. But if it's down here, it will be negative because it's not an S. So that means that sine theta can be positive or negative, and the value of sine theta we get from the triangle. The hypotenuse we get by doing 1 squared, add 3 squared, and square root it. Okay, so it's going to be opposite over hypotenuse, and really we should rationalise that denominator, shouldn't we? Okay, so that's it. Right, number 7. Number 7 looks like strange wording, but it's going to be fine. So what have we got? S is sine x, and 90, x is between 90 and 180, and we have to express cos x in terms of s. Okay, right, I'm going to write this the other way around, and then it looks very much like the questions we've just done. Okay, we can use the trig identities for this, but again, I think this is easier using a right angle triangle. So I'm going to draw myself a slightly wobbly right angle triangle. I'm going to pick an angle for x, and sine is opposite over hypotenuse, so I'm going to make 1 be my hypotenuse, okay, and s is my opposite side. So if I want to find the adjacent side, I'd need to do 1 squared take away s squared and square root it. Okay, right, so I'm also going to draw myself a cast diagram, and we're looking in the region from 90 to 180, so that means we're looking in here, aren't we? Alright, if you imagine your angle x is going there. So we know that sine is positive, but we also know in this quadrant cos is negative. So that means cos has got to be minus, and then it's adjacent over hypotenuse. So the adjacent is 1 minus sine s squared, over the hypotenuse is 1, so that's it. Okay, now this may be familiar to you. Cos squared is 1 minus sine squared. So cos would be the square root of 1 minus sine squared. But the cast diagram is where we get our negative from, or you could consider the graphs for 90 to 180. Okay. I'm actually going to jump to question 11 because it's kind of on the similar lines to number 7. Okay, right, in question 11 we have got t is equal to tan x, okay, and we have to express all of these different things in terms of tan. So first of all we've got cos squared x. Now I don't know an identity that relates cos squared to tan squared, but we'd have to use a combination of sine squared and cos squared and tan squared, and I will show you that as well, but I'm going to show you how easy this is using our right angled triangle situation. So let's have our right angled triangle. Tan x is equal to t, which is the same as opposite over adjacent, so I'm going to put 1. Okay, here's my right angle, I'm going to put my x down there, opposite side t, adjacent side 1, and we can work out the hypotenuse by doing 1 squared add t squared, so 1 plus t squared. Okay, so if we want cos squared, then we want cos squared, okay, which is adjacent over hypotenuse, so 1 over 1 plus t squared, okay, and that, oh sorry, I've just realised for the hypotenuse you'd have to square root your answer, wouldn't you? There we go. So this is 1 over the square root of 1 plus t squared, adjacent over hypotenuse, and then we square the whole thing, which gives us 1 over 1 plus t squared. Now if we'd done that using an identity instead, this is what it looks like. It's a bit of a faff. So we know that tan is sine over cos, okay, so we know that tan squared is sine squared over cos squared, okay, and we know that sine squared is 1 minus cos squared over cos squared. So I now have an identity that connects tan to cos, okay, so I can replace my tan with t. Okay, now all I need to do is make cos squared the subject, so let's multiply through by cos squared. Okay, let's move all the cos squareds to one side. Okay, well let's factorise. And then let's divide through by t plus 1. Okay, so, oh, t squared, it should have been t squared all the way through, shouldn't it? There we go. That's better because it was tan squared. And that gives us the same answer as we got from our triangles. Okay, I can use that same triangle to answer the other questions. Okay, so the next one, B, is express sine squared x in terms of t. So if we use the triangle, that is the opposite over the hypotenuse. Oops. Okay, and then that would give us sine, and then we need to square it. So if we square that, then we're getting t squared over 1 plus t squared. Or you can follow a similar process to the one we've just done there. Okay, so then that means if we are doing part C, sorry, there we go. So part C, we've got to express cos squared x minus sine squared x in terms of t. Well, we know that cos squared x was 1 over 1 plus t squared, and sine squared x was t squared over 1 plus t squared. Okay, then we know that this is just going to be 1 minus t squared over 1 plus t squared. Okay, right, and then the last one, D, for number 11, is 2 over sine squared x plus 1. Okay, so this is 2 over t squared over 1 plus t squared. Okay, plus 1. So essentially we've got the reciprocal of this. If we do 2 divided by this fraction, it's the same as 2 times the reciprocal. So we've got 2, 1 plus t squared over t squared, plus 1. Now let's make it over a common denominator just to tidy things up. So we'll do over t squared. T squared is equivalent to 1. Okay, just going to connect it with my equivalents, and then just expand and tidy. Okay, and that's it. So really C and D follow from A and B, and A and B I prefer using a right angle triangle for, but you can use the identities in a lot of rearranging.